Hi and welcome, ladies and gentlemen. Today we are talking about post-order traversal in binary trees. Well, if you want to traverse a binary tree, then you have basically the choice between in-order, post-order and pre-order. Have a look at the other two videos. I blend them in step by step up at your screen. Well, in the post-order traversal, you will traverse from first the left subtree, then the right subtree, and then the root, which is basically also a depth first search, where you go to the first leaf of the left subtree, then you go further to the right, and so on and so forth. Alright, I want to mention that you find the source code of this tutorial in the description down below. There's a link to my Git repository. Alright, so let's have a look at the traversal itself. At first we started our root node and we said we want to traverse the left subtree. So from our 1 we go to our 2 here. That is a tree by itself again, so we go again to our left subtree. So we are at the 4 now. What now happens is that the 4 is a leaf node, so we are done here and we can append the 4 to our result. Alright, then we go back to our 2 and see, oh, it has a right subtree. So we go to the 5, and since the 5 is a leaf node 2, we can append it to our result here. Then we are done with all the subtrees of the 2, so we can append our root to our result, and we are done with the whole left subtree there. Alright, so we are back at the 1, the left subtree is done, so let's go to the right subtree, which is 3, 6 and 7. There we go at first to the 3, and we see the 3 has 2 children, the 6 and the 7, so we go to the left subtree again. And that is the 6. The 6 has no children, so it is a leaf node. And that means that we are done with the 6 and we can append the 6 to our result. In the next step, we go back to our 3, see that it has another child as a right subtree. So we go to the 7 and then we see that the 7 has no children. It is a leaf node, so we are done with the 7 and we can append it to our result. Then we are done also with the 3, so we can append it to our result. And then we are done with the whole tree and we can append the 1 as a root node to our result list. So let's have a look at the algorithm itself. Well, at first we have our empty list, which is the result list. There we will store the nodes that we worked on. So then we have to check if our current node is a leaf node. If so, we return a singleton list with our node because we are done with that. Alright, so in the next step we want to append to our result all the results of the left subtree, so we invoke there our method again on the left subtree. We do the same with the right subtree, and once we are done with all the right subtrees, then we can append our root node. And when we are done with the whole tree, then we can return the result. Alright, let's implement that in Python. For that I want to use another tutorial where I explained the binary tree in list representation. I blend in a link now, so you can have a look there if you want to repeat that. Alright, so for that I create a new file here and I call that postorder_traversal.python. And there I copy now the source code of the binary tree as list, because I want to use it and I don't want to write everything from scratch. But the main idea is that we have a node here and we have a left and right subtree, and every node has also a value. And we have as a root node in the tree, in the whole binary tree, our root. Alright. So then we have here some methods for printing and inserting. So have a look at the binary tree as list video, to know what's exactly going on there. Alright, so let's invoke our post-order traversal, and for that I create a method here, post-order traversal, and that gets no arguments, it just gets self because we want to invoke it on the whole tree. And then here I just say invokes the post-order traversal on the tree, and I say returns a list of nodes in post-order traversal. And here I want to say pass for now, because we want to invoke this method recursively, and for that I need a little helper method that does all the work. And I create now here a private method, that's why there are the two underscores, and I call that post-order traversal rec for the recursive variant. And there I say self, and it gets a node, the node we are currently working on. And as I showed you earlier, we go in and say at first we have an empty result list. Then we want to check if the node we currently work on is a leaf node. So if node.left is equal to none, so the left node is the left child is none, and if node.right is equal to none, then we have a leaf node, and we can say return, and there we want to return our singleton list with the node inside. I have to say that in our node, the left and the subtree are initialized with none, so we can really do that, and we never set the value if we don't create a node there. Alright, so what we want to do next is we want to traverse the left subtree if there is one. So if node.left is not equal to none, then we want to go in and say self.postOrder traversal, and we want to invoke it now on our node.left. And that gives us a list back of nodes of the subtree in their pre-order traversal. So we can say here result.extend, and we extend the result of our recursive variant, or of our recursive method. And after that we want to do exactly the same with our right subtree. So we go in here and we want to do that here and there on our right child. So now we are done with our children here, and then we go and append result, append the normal node to our result. And now we are done with the whole tree, so we can return our result. Okay, so good so far. That should solve our post-order traversal. Now we just need to invoke it here in our method, and we have to give it an initial node, and that will be our root node. So we can say here return, since we want to return a list of nodes, and we get that from the recursion. There we go in and say return self.postOrder traversal rec, and we initialize that with our root node. So here root. Alright, here I create the binary tree already, and that will be the tree you saw earlier in the slides. So as root node, the first one was the 1, the first left child 2, the right child 3, and so on. So let's make here a print just to separate this breadth first search or breadth first traversal of the tree to print how it looks. And then we come in here and say for node in, and there I want to get our result. So I say here that is bin tree dot, and there I want the post order traversal, I invoke that, and as I said earlier, that gives us a list of nodes, how they look in pre-order traversal. And then I want to say here print, and I want to print our node.value. Alright, let's try if that works. So it doesn't work exactly, and here it says it doesn't know my post order traversal rec in line 103, and here we have post order traversal rec. That is true. And then I hope it works now, and it looks good. Alright, so what happens? At first we are at the 1, we go to the 2, and then we go again. The next left subtree is a 4, this is a leaf, so we print it. Then we go to the 5 and we print it again, which is the right subtree of the 2. Then we print the 2, we did that. Then we go to the 3, it has children, so we go to the 6, 6 is a leaf, so we print it. The 7 is a right leaf, so we print that. Then we are done with the 3, we print that, and in the end we print our 1. So as you see, it works. Alright, ladies and gentlemen, if you like this video, give it a thumbs up and tell me down in the comments below what you think about it. Yeah, I really appreciate if you subscribe to the channel to always get informed whenever I'm uploading new videos. That's it for me. Have a great day. Bye.